Alright, today our objective is to convert a word problem into an equation. So your first example on your sheet, because all of you have handouts right now, is that a roller coaster has red and white cars, and the total number of cars is 12. If a third of the cars are white, how many cars are red? So, first of all, bear with me today because I have a cast, so I'm not left-handed, but I'm going to try to write anyway with my left hand. So the first thing we want to do when we're solving word problems, because the words are kind of long and messy and we don't want to write everything out while we're solving it, is just to label variables. So, for some reason, we really like to use the letters X and Y a lot. Like we've done with graphs a lot, you know how like you have the X variable and the Y variable, and then we solve. So we want to put our word problems into letters. So for the roller coaster problem, we have some variables, and what do you think those would be? And feel free just to shout out what our X and Y could be.
Red cars and white cars.
Exactly. So which do you want to be which? Which is X?
X should be red. Yeah, I agree.
X should be red. And you don't actually want to write just that X is red cars. We actually want to write that X is the number of red cars and Y is the number of white cars. And just so it's kind of like we have a complete sentence, we usually call this a let statement, and we start with saying like let X equal the number of red cars and Y equal the number of white cars. So after that, we want to look for some key words. And so number 2, look for key words. And what would some of the key words be here that would help us translate this into an equation? Any ideas? Yeah, Sarah?
Total number of cars is 12.
Good. So
Total, that'd be a keyword.
exactly, perfect. And from would it be? Let's see. So the operations we're going to work with today are subtraction, addition, equals, division, multiplication. Sorry if I said that wrong. But we want to translate our keywords into these things. So what would total probably be on this list?
Equal.
Exactly, good. Okay, and does anyone have any random words they think they could add to this list? Sarah.
A third.
A third?
I
Okay.
feel like that's division. A third.
Yeah, well, we would write a third, like 1/3. But what we want to note here in specifically is what comes after a third, so the word of. And the word of usually indicates multiplication. And some other words are product. Let's see. I wrote some out. For plus, we have and, some. Let's see. In addition to total, for equals, we often use words like is, were, like the whole to be. So conjugations of to be. Is, were, was, etc. Let's see from this example. So like in this example where we have red and white cars, you can see like it would be X plus Y cars. Can I get a volunteer, someone who's really brave and wants to try translating a couple things into equations? Wow, Sarah, you're on fire. Okay, so come and grab a piece of chalk. Oh, you already have one. Look at you. You're so prepared. Okay, so somewhere where I haven't scribbled all over, do you want to try writing that the product of red and white cars is 32? Do you think you can do that? The product. What over here, which one was that?
Multiplication.
Okay.
So the product of red cars, which is X, and white cars
Yeah.
is
And I said
32.
Awesome.
And this is times.
Yeah, just a disclaimer. We can write this as a dot, like the multiplication, or we can use parentheses. Or when we're doing variables, we could also write it just as x and y. And we usually do that instead of the cross because it gets confused with the x. Yeah. Okay, thank you, Sarah. Do I have another volunteer maybe? Haley! Great. So what I want you to try to translate is the number of red cars decreased by the number of white cars is 4.
X is red cars.
Yeah. Nice. So what would decreased indicate?
And minus sign.
Good. Thank you, Haley.
You're welcome.
Are there any other words you guys can think of that would indicate a minus?
Less.
Yeah, absolutely. Let's see, what about division? Is there anything you guys can think of that would indicate division?
Divided by.
Yes, absolutely. Some other ones are per. Like if we have like 5 cars, passenger or something that could indicate division for a problem. Quotient is another good one. Okay, so we haven't actually set up the equation for the word problem yet. So once we've identified our keywords, finally, the third step, as you can imagine, and like we've been practicing, we want to write out the equation. And the fourth step, if you're actually doing this, is to solve the equation, which we're not going to do today because we've been learning how to solve equations all year. So now we just need to apply it. Okay, so then we have our next example, which is Marissa is Jamie's older sister. The difference between their ages is 3 years, and Marissa is twice as old as Jamie. What are their ages? So how would we do the let statement for that? So we have our x and our y. What would our x and y be? Yeah, Marie?
Let x equal Marissa's age and let y equal Jamie's age.
Okay, and then next we want to look for some keywords. So what would be some of the keywords in that one?
Different.
Okay, and that indicates?
Subtraction.
Exactly, and you guys can feel free to add different words to your notes as you learn more. So, so x minus y equals 3, and then what would be the final equation that we could set up?
2x equals
And that's actually a common misconception. It says Marissa is twice as old as Jamie, so you want to say like 2x equals y. But if Marissa, the x, is twice as old as Jamie, it's actually going to be x equals 2y. Because if you multiply Jamie's age by 2, then you'll get Marissa's age. So, as a disclaimer, when you have the words as or then, it's usually set up the opposite way that you would first read it. So if you have like less than or twice as, yeah, this is wrong and that's right. And I believe we're out of time, but you guys did great, and for homework you can solve the third problem. Thank you, Ms. Mollee.
Thank you, Ms. Mollee.
Yeah.